Okay, guys. So, functions and relations. Um, so let's talk about what a relation is. Probably what you're used to when you think of equations or whatever, you're used to something like this. Well, this is a function and it is a relation. All a relation is a connection of two things. So if we draw little things where we say, okay, these are going to relate in specific ways. So we're going to do sandwich toppings. We're going to do peanut butter, jelly. These are related. If we do ham, cheese, these are related as well. If we do mustard, well, that's probably going to go with ham and cheese. Tomato. Well, I mean, that's definitely not going to go with jelly, but it could still go with ham. So all we do is just create a list of things that are related in some way. And then these lines kind of talk about the relationships. What this is called is a mapping. It's a list of things on the left that are related to things on the right. This on the left, this is what's called the domain. And this is what is called the range on the right. And domain and range can overlap, and that's perfectly fine. Numbers, though, they give us a little extra ability when we do things like this. They give us the ability to create relationships between things that aren't just listed like this. So we can do a list of relations like one is related to two, two is related to three, three is related to four, two is related to four, one's related to three. And we're not necessarily telling how they're related. We're just saying, okay, they're related. We can also write this in a different way. We can write it as 1, 2, because of this relationship right here, 1 is related to 2. We can say 1 is related to 3. 2 is related to 3. 2 is related to 4. And 3 is related to 4. And again, we're not really telling how they're related. We're just saying that they are. So this is the same thing as this. All we've done is just written it as a list instead of as a chart. So when you go to identify your domain, you can say, okay, this is our domain, this is our range. Well, down here, what is our domain and what is our range? Well, our x values over here are our domain, and then our y values are our range. And you can kind of think of this as a factory that puts in things and then pops out things. So we put in a 1 and we can get out a 2, or we can get out a 3. We put in a 2 and we can get out a 3, or we can get out a 4. But we put in a 3 and we can only get out a 4. And this is the main difference between functions and relations. Relations can look like this, and they can be kind of a convoluted mess of lines and all that. But for functions to work, we can only have one line. So 1, 2, 3, 7, 8, 9. We can only have one line that goes between these things. So what we're looking for over here to determine whether this is a function or just a relation is how many lines are coming out of each of these. If the answer is 1, then it's a function. If the answer is more than 1, not a function. 2, 3, 4, doesn't matter. So what that would look like could be this. And them crossing like this is okay. But the two lines coming out of 2 right here, that's not okay for it to be a function. So when you're looking at mappings like this, what you need to look for is one line out of everything. When you're looking at things like this list up here, what you need to look for is the x value. You don't want it to repeat. If it repeats, so like 1 right here, it does repeat. But what you need is this to match this. So if we had if we had 1, 2 right here, then that would be fine, because all we would have is one line out of 2, or one line going from 1 to 2. We would just have listed it twice. But when we have 1, 3, we're not getting anything consistent anymore. Sometimes we're getting a 2 and sometimes we're getting a 3. So that makes it not a function for sure. Like I said, numbers give us kind of special abilities with stuff like this. And the difference between like the sandwich toppings example and numbers is that numbers go from 0 to 100, and they go up and down. You can tell the relationships between them. So if we can do something like a graph with numbers, whereas we can't really do that with sandwich toppings, because there's nothing, like we can't put ham sandwich right here and peanut butter right here and jelly right here. It doesn't make any sense. So the graph is something that we can only do with numbers. So when we graph something like this, then we still have a relationship right here. We have 0, 0 right here. Maybe this is dollars made per hours worked. Maybe you make each of these is 10 and each of these is 1. So you work 1 hour, 2 hour for 1, 2. So you get 2.30. You work 2 hours and you make $30. You work 4 hours, so right here, and you make $60. So this is still a relationship. It's just kind of simplified with our graph, because we don't have to write out, we make $15 every hour. So right here, it should be 1.5 or whatever. We don't have to worry about that with the graph, because we've got it all identified with this one line. And sometimes these can still be relations, and sometimes they're still functions. And the way you tell with that is you use the the vertical line test. And the vertical line test is where you lay your pencil down across the paper vertically like that, up and down. And then you drag it across your line and you leave it up and down. And if it touches the line anywhere more than one time, then it's not a function. But like in this case, if it touches only one time everywhere, then we're good to go. This is a function. So if we had something that looked along these lines and we dragged it across, we would say, oh, well, right here, it touches right here, right here, right here, and right here. So this is not a function. Whereas just the line going here, here, perfectly fine. This is a function, because we don't ever touch this line more than one time with our pencil. So that's just one way that you can identify functions versus relations with just using a graph. So if you take this and you draw it across like this, then this is just a relationship. This one that we did a minute ago. But with the black line, this is just going to be a function. So a lot of times what your work likes is it likes ordered pairs. So it'll make lists of numbers like this. And like I said, what you're looking for here is X values that repeat. If you don't have an X value that repeats, then you are good to go. So we've got -1, I don't see another -1, -2, I don't see another -2, -7, there's not another -7 with our X values. That's all we're worried about right now. There's not another 6 with our X values, and there's not another +7 with our X values. So this is a function because none of our X values repeat. If they did repeat, if we had -1, 3, then we look and we say, okay, -1 up here, -1 back here, are these the same? If they are, we're good to go. It's still a function. If they are not, like they are in this case, it is not a function. So if we had 2 here, then this is good to go. We're still perfect. This is still a function. But if they don't match, we're not good to go. So if you can't remember how to do that whole process, then what you can do is just draw it as a graph. You can plot each of these points, or you can do it as a mapping. And I like mappings for these. I think they're very helpful. -1, -2, -7, 6, 7, and -1. I'm just going to make my circle bigger. And then we go 2, 1, 6, -7, 5, 3. And then we draw our lines. So -1 goes to 2, -2 goes to 1, -7 goes to 6, 6 goes to -7, 7 goes to 5, and -1, we've already got it written up here. So I'm just going to erase it down here and use this one from up here. So -1 goes to 3. So when you look at this, it's a lot easier to see whether things are a relation or a function without having to look through all these values and maybe miss something. Right here, you're looking for, remember, 2 lines coming out of any of these. So we have 2 lines coming here, so this is not a function. But if we go back to the original problem, which was this line disappears. And then we don't have 2 lines coming out of any one point. So we are good to go. This is a function. Sometimes these are also represented as tables. Just the table would have a line down the middle, X, Y, and it would list all your X values over here, -7, 6, 7, and then it would list all your Y values over here, 2, 1, 6, -7, 5. And you can do this the exact same way as you would do the other ones. You're looking for repeating X values. And you do this the same way you do this. And if you find something that repeats, then it's not. If you find something that repeats and maps to something else, it's not a function. This right here is good to go. It is a function. It's just a different way of writing these same things that we've been writing here and here. They're all the same thing, just represented differently. So you can convert between them if it helps you. So just know that any of these can be converted into any different thing. The last thing I think we'll go over is graphs. So if it gives you a list of points and says graph these points, so I'm not going to work a specific example. I'm just going to write down some points. So if we have this point, this point, and this point, and it just listed all these points up here and told you to graph them and use the vertical line test. Well, what you would do is graph them, and what you're going to want to do is put a line between them. and you're going to want to connect them up like this. But that is not what you should do, because these points are just disconnected points. They're not necessarily connected like a line like usual. And then you're just going to use the vertical line test. So you're going to drag it across, and if it touches 2 points at one time, then we're not good to go. So right here, it only touches that point. Right here, it only touches that point. And right here, it only touches that point. So this is a function. But if we had another point right here, and we dragged it, we would get right here, and we would say, okay, well, it touches right here, and it touches right here. So definitely not a function. So all you have to look for is if it touches more than one time.